Hi, everyone. This is Tom Henthorn, and I'm here to talk to you today about a subject that we don't often cover in anesthetic clinical pharmacology, and that is urinary clearance and urine concentrations. Much like propofol, THC is highly lipophilic and rapidly distributes from blood to tissues, making its detection in plasma problematic after only a few hours after it's used. Unlike propofol, forensic toxicologists are interested in detecting the presence of THC use hours or days after its effects have dissipated. Therefore, there is an extensive literature that is focused on the detection of THC metabolites in both blood and urine, because THC is long gone. The THC metabolite, carboxy-THC glucuronide, makes up the preponderance of THC metabolite in the urine. For laboratory convenience, most urine assays first hydrolyze the carboxy-THC glucuronide to carboxy-THC, so that the results include both a very small amount of THC COOH as well as carboxy-THC glucuronide. There are sometimes efforts to interpret these urine assays quantitatively, which results in two main conundrums. First, there is no pharmacokinetic model for urine excretion of carboxy-THC or carboxy-THC glucuronide, which makes interpreting these results a problem. There is also variable dilution of the carboxy-THC glucuronide in the urine, depending on the rate of free water excretion by the kidneys. Thus, correcting urine carboxy-THC glucuronide concentrations with the concentration of creatinine in the urine is a common practice among forensic toxicology labs. So our goal here was to create a pharmacokinetic model of carboxy-THC excretion from already existing data. We wanted to examine the relationship among urine production rate, urine creatinine concentration, and the stability of creatinine clearance over time. So our methods were to go back to the landmark Maryland Eustace studies that were done at NIDA starting in 1992 and going forward until the mid-2000s. In this study, 6 young male adults were admitted to a clinical research center on 2 occasions for at least 1 week each time. On day 1, they smoked a cannabis cigarette with either 1.5% or 3.5% THC via a computer-controlled inhalation-exhalation protocol. Then, for the next 7 days, all the urine was collected. Each collection's volume and time were recorded. Concentrations of carboxy-THC after acid hydrolysis and creatinine were measured. Plasma samples were also obtained for measurement of THC, 11-hydroxy-THC, and carboxy-THC. These plasma data and subsequent population PK modeling were presented here at ISAP in 2019 and have been published last year. Here, we're going to construct a population pharmacokinetic model of only the urine carboxy-THC data, examining creatinine concentration and excretion rate as potential covariates. This is what the data looked like. So Maryland Eustace published every single data point in this study. There are 6 pages, just like this one, in which the time The concentrations of carboxy, THC, and creatinine were recorded, and the volume of urine collected in each subject during each of the 2 weeks. Alas, there was no Excel file for this, and I had to go through and hand enter all of these data. So this is the basic schematic of what's going on. So you inhale the delta-9 THC. It's converted to 11-hydroxy-THC and carboxy THC. The carboxy THC is then glucuronidated in a phase 2 reaction, and then that makes its way into the urine. So the way the model is constructed is that we gave the THC dose to each individual that was already predetermined. And it appeared as carboxy THC in plasma. From there, it is cleared either by urinary clearance into the urine or by some other unmeasured pathway. So let's start looking at how much data we had and what some of it looked like. Here we have the urine creatinine concentration on the y-axis and the urine flow rate on the x-axis. And as you can see, there is a significant negative correlation. What you can also see is that the amount of scatter is truly amazing. And it was a surprise to me to see that there was such a poor correlation between urine flow and urine creatinine concentration. One of the potential causes for this is that the creatinine clearance may not be absolutely stable, and we wanted to look at that. Now, I will caveat this with saying that even though multiple measures of urine creatinine concentration were made in this study, not a single plasma creatinine concentration was determined. So what I have used interchangeably here is creatinine clearance, assuming that the concentration was 1 microgram per mil in the plasma, or that this is simply the creatinine excretion rate. You can look at it either way. And you can see here that over the period of 1 week, this is one subject, and over the period of 1 week, on both occasions, the creatinine clearance is highly variable collection to collection. I have talked with our transplant nephrologist, who was a Clin Farm fellow at Northwestern when I was there, and he said this is well known among nephrologists, that the creatinine clearance changes with things like eating meals, changing your posture, exercise, you name it, it goes up and down. And that's one of the reasons that they prefer just looking at the plasma creatinine these days. The creatinine clearance is rarely actually measured. But this just gives you an idea of the scatter. So this summarizes some of our modeling. We looked at 1, 2, and 3 compartments for the plasma carboxy THC and found that the most parsimonious was a 2-compartment model. And then when we took that model and moved it into potential covariates, both creatinine and creatinine clearance were significant in reducing the objective function. And when added together, we got only a minor decrease, and it's not significant. So creatinine clearance was chosen as the most significant covariate for carboxy THC clearance into the urine. This slide summarizes our parameters. As you can see, there's the two-compartment model for carboxy-THC, has a very large volume of distribution. As we had noted previously, the elimination clearance is approximately the same as a glomerular filtration rate. However, only a very small fraction of that total clearance is actually shows up in the urine. These are some of our diagnostic plots. The observed versus predicted in the urine was very tight, and the scatter was didn't change much. There was no obvious deviations over time or over the various concentrations. These are the visual predictive checks that show that for the low concentration on the right, on the left, and the high concentration on the right, you can see the model prediction was reasonably good. And you can also see here how nice the cumulative urine concentration data look, and that we are plateauing. And so the total amount of showing up in the urine of the dose smoked has plateaued and is not expected to get much bigger by going beyond a week. For fun, we took the typical values of the plasma carboxy-THC model, which was determined completely from the urine data, and just put it up against the actual the plasma carboxy-THC concentrations from the plasma study that we published previously. And you can see the urine data actually drives through about the middle of both doses. There's a little bit of bias on low dose, but it sure nails the high dose. And just to point out, we did not include these data when we did our modeling. This is all post hoc. So in conclusion, creatinine clearance is a significant covariate for urinary carboxy-THC clearance. Only about 2 or 3% of bioavailable THC is excreted via the urine. So where is the rest of the carboxy-THC glucuronide going? It's been speculated that it is excreted in the bile and shows up in the feces. That isn't good news for people wanting to do pharmacokinetic analysis. The creatinine clearance varies over time in healthy subjects. We thought that was interesting. And urine creatinine concentration is not highly correlated with hydration state as reflected in urine flow rates. So correction of urine drug and/or metabolite concentration with urine creatinine concentration or specific gravity may be more problematic than previously appreciated. I'll be around to take any questions. Thanks.